This video is going to be dedicated to making castable thermite, and I did a regular video on thermite called Making Thermite. Some of the details are more in that video about the reactions themselves, just in case you want to check it out. Some information here. Its first making isn't attributable to any one person in particular, but it's thought to have come from a military contract in the 1950s. Go figure. One of the simpler ways to make castable thermite is to use calcium sulfate, which is plaster of Paris, is not very expensive at all, as the oxidizer, plus the aluminum as the metal. The calcium sulfate is mixed with fine aluminum powder in a 2-to-1 ratio, calcium sulfate to aluminum by weight. The reaction for this is 3 calcium sulfate plus 2 aluminum yields 3 calcium oxide plus aluminum oxide plus sulfur dioxide. And just a note, that of course is toxic. If you want to make a hotter castable thermite, you want to add iron oxide. And the original ratio I looked up was calcium sulfate to 2, aluminum to 2, iron oxide 6. That would be the ratios right there. But I messed around with this a little bit on my own before I did this video, and I found a ratio, and this is what it is. It's 5 for calcium sulfate, 4 for aluminum, and 10 for iron oxide by weight. And by my opinion, at least, it worked a lot better. The reaction for the addition of the iron oxide only is 2 aluminums plus iron oxide yields aluminum oxide plus 2 free irons. However, of course, this iron oxide is mixed in with the original calcium sulfate and aluminum, so the overall reaction is 4 aluminums plus iron oxide plus 3 calcium sulfates yields 2 aluminum oxide plus 2 free irons plus 3 calcium oxides plus 3 sulfur dioxide. And once again, sulfur dioxide is toxic. I mentioned the word hotter here as a castable thermite if you add iron oxide, and I went and looked this up. I did not figure this out on my own, but the heat produced, which is called enthalpy, from a calcium sulfate and aluminum mix only is negative 173.3 kilojoules per mole. If you go with regular thermite, iron oxide plus aluminum, it's negative 851.5 kilojoules per mole, and this is 5 times more than what this is right here. So it is obviously going to be hotter if you add the iron oxide to this ratio or any other ratio, because this is the main reason that the heat goes up. And the reason these are negative is that the compound all by itself is at 0 and it's giving off heat, so it's losing heat, and therefore that's the enthalpy, or the heat produced, is always noted as a negative number. If time permits, I might also try calcium sulfate, aluminum, and copper oxide together as a castable thermite, and also trying to use a different binder to cast the thermite. Our materials we need are calcium sulfate, aluminum, iron oxide, if I get to it, copper oxide, and water. And the water, of course, is going to depend on how these are mixed and how much of each one needs how much water. Our methods are as follows, really straightforward. So we're going to take each one of these and mix them appropriately, and we'll see how that goes as we go through the video with the weights, etc. Mix them dry well so that there's no clumps or chunks in them. Then add water slowly. While you're mixing, you want it to be just a little bit thinner than maybe pudding. Then pour it into a mold or into your cup or whatever you're going to use, and allow it to set. Now it's still wet, but it's set because the calcium sulfate, which is plaster of Paris, is set. So it's wet, but you can handle it easily. Then you want to put it on something hot, like a hot plate, to dry it out and remove the water. You want to start low and go high. If you go high right away, these can break apart or crack. And then finally, we light them with a sparkler. No surprise there. That's all I wrote, so let's go make some castable thermite. For the first test, 20 grams of calcium sulfate pre-weighed and 10 grams of powdered aluminum pre-weighed. Ready to go with our test. So I'm going to dump the aluminum into the calcium sulfate here. And you want to start by mixing these two together as best as you can while they're dry. Okay, I have 50 milliliters of water here exactly, so I'm going to add it slowly. So this is what you want. You want a slurry, but a pretty running one, so you can pour it out easily. And I'm going to do that now, and I'm using a plastic cup because when this hardens, you want to be able to squeeze it. I'm going to show you here from the sides or push from the bottom to get it out. Done. All right, I'm just going to smash this down to get most of it at the bottom. Obviously, I made a little bit of a mess there, but that won't matter in the end. That just needs to harden. Half hour later, this is a rock hard. Doesn't take a long time, so I'm just going to work on it slowly here, trying to get this out. So I got a little hammer here I'm going to hit it with. There it goes. Yay! All right, so you can see it got chipped up a bit. This is just a test here. What I'm going to do now is drill a small hole in it before I heat this. It needs to be heated for the water, all the water to come out of it. And that'll be the place that I put the sparkler in when we're done. Most sparklers are about 1/8 of an inch thick, so I chose 2 sizes up, which is 9/64 turns out. All right, that should be enough. It's on the hot seat. Okay, let's just turn this on and wait for this to dry out. It's been on here for 1 hour, and that is good and dried, so let's stick a sparkler in it and try it out. And it is done, and it's rock hard. Here's an old piece that was laying around from earlier, and you can see, I mean, that crumbles super easy. It's thin anyways, it's not a great example, but very different, of course. Now that it's been sort of hardened and cured, so to speak, I'm going to put the sparkler right in there like so. It's that simple. Since this is just a test, I'm not going to see what it might burn through. In general, as I mentioned, calcium sulfate and aluminum thermite really doesn't get that hot. Not as hot as others, but let's try it. You couldn't tell from the earlier clip that it's night out here, but it is. What a better time to try some thermite out. There we go. Nice. Didn't think that was going to work at first. So that is molten aluminum there, a little bit on the side, etc. But yeah, that was cool. Very cool. Ramping it up, 60 grams of calcium sulfate, pre-weighed, and 30 grams of powdered aluminum, pre-weighed. Ready to mix the second batch. I'm going to mix these together dry again. Okay, we're going to let that settle down. I'm going to put this into the cup first before I add any water. This is a zinc cap that went to a D-cell battery, a standard battery, the old ones, and I cut off the top to make it nice looking because it was all chewed up. What I plan on doing is mixing the water in here and then putting some in here and burning the calcium sulfate and aluminum thermite in here with the zinc around it. I don't know, just to see what happens next. Adding the water. You need it running like that, typically, if you're going to pour it like I am right here. Maybe a touch less water, but this will work just fine. Okay, we're going to let that harden up. There's no need to remove this. It's going to stay as is. I'm just going to use scissors to cut this open. All right. Put it on the hot plate. Well, this one has to go on there too. And now for the simplest of maneuvers, just putting the sparklers in these holes. These are a bit thicker. I think they might be colored sparklers. Regardless, I had to drill a bigger hole. And also we saw from that time lapse in the back there, if you noticed, that blackboard was spattered. So it looks like if you put too much water in, that's what ends up happening. I'm going to try this one in the zinc cap first. This metal is not all that thick, but I know calcium sulfate and aluminum thermite is not the hottest either. So we'll see what happens. This probably won't do anything, to be honest, but I'm going to try it. Nice. There's some molten aluminum and zinc mixed together because that can is gone. I've seen this once before, but see that fluffy stuff right there? I've seen that when I melted pennies using amperage, and that fluffy stuff I think is zinc oxide. Just kind of flows, it's very thin, and if I touched it, it would just break apart immediately, but I think that's what that is. Just interesting. All right, here goes the big one. Oh, it didn't get through either. Pop off some of these and we'll see what they look like once they're cooled down. Since we're working with castable thermite, let's make something worthy of being casted. So you can barely see it, but there's a box in the back here. There's some aluminum foil right there. And inside that box, I have a rubber ducky. What I plan on doing is taking the aluminum foil, lining the inside of the box. Then I'm going to pour the calcium sulfate or plaster of Paris, just a layer on the bottom here, let it harden, put the duck down, and then fill the rest of it with plaster of Paris so the duck is stuck in the middle of all of this stuff right here. Then I plan on taking a hacksaw and cutting it down the middle, and therefore cutting the duck in half, giving us 2 halves that we can pour our castable thermite into. And then afterwards I'll glue them together, and we'll make a rubber ducky thermite thing. Yeah, let's give it a try. I glued in some styrofoam just to use up some of the space. It was just really big for what I want. So I'm going to take the aluminum foil here and simply crunch it in here. Okay, I think I'm going to run one other piece going this way and I'll be done. It's done. In goes the first layer here. Messy. We just need to wait till it's done. This not only needs to harden, which will happen here in about 15 minutes, but it also needs to dry out. We were using the hot plate to speed that up with the Thermite earlier. I could put this in the oven. I'm a little bit worried about the styrofoam melting, so I might just let this air dry. What I did next was drill holes in here, so when I pour the next layer that sticks to the bottom layer, I just don't want them separating. And I have here the rubber ducky. I covered it in Vaseline, good and shiny so it doesn't stick. And I don't know how much that'll help because I've actually never done this with the rubber duck. So we'll see what happens. But it's centered. That's what that line's all about. So I know where to cut it. It's over here and here. And what I'm going to do next is fasten this to the bottom so it stays centered with some tape over it, and also keep it from floating to the top. I tried putting the tape down here on the plaster of Paris and then tape over it like so, and it wouldn't hold to the plaster of Paris. So I did this kind of funky thing. Well, here it goes. I'm going to go a little bit on the slow side. Okay, that's a big mess, but hey, that's what Plaster of Paris does. You know, like so many projects, things just don't quite go the way you hope they would. And one of those was I was dropping this on the ground flat to get the stuff to settle around the duck, and it accidentally hit on the edge here. I didn't really notice it until later, and it hardened this way. So I'm assuming most everything shifted this way a bit. So when I cut it, I'm going to cut it slightly offline here. It doesn't really matter. As long as I can get through the duck and pull it out of the stuff to leave a nice impression, I'll be happy with that. So we can make a Thermite rubber duck. But also, I plan on cutting this box off of the brick of Plaster of Paris because I just realized that it's hard. It's rock hard, of course. And so I can cut this away. Probably, yeah, the aluminum foil is going to pull away nicely. And therefore, I don't have to worry about the styrofoam. I'll put it in the oven and let it cook that way to dry it up quicker. Here it is, completely free. So it's going in the oven. These little short marks were the marks off the box. I moved the line over about 3/16 of an inch, hoping that it makes up for the movement this direction. Well, into the oven this goes. Supporting that with one hand is even a little tough, man. Been in there for 3 hours. Here it is, dried out nicely. But one quick comment. I put this in originally for 3 hours and thought it was done. Then I decided to drill a hole on the side, a small one, over on this side here, and the inside was wet. So I put it back in, didn't want to bore you with that, and it took another 6 hours for it to dry. I'm not even 100% sure it's dry in the middle, very middle. So, but I'm going to go ahead and cut this anyways. I don't think it's perfectly down the middle of the duck, but it's pretty close. So like I said, it's not right down the middle. It's pretty close, but I noticed just now there's cracks here, maybe from where the thicker stuff and the thinner stuff didn't mix right. Oh yeah, that's like going to come off a little bit maybe. Anyways, I'm going to glue that there before I move anything like taking the plastic out. So I'll be back. Some of you may have laughed when you heard me say, so I'm going to glue this together. Well, turns out you can't really glue plaster of Paris. I've never tried. And the problem is it's kind of dusty. And even if you wipe that away, the glue sticks to the top layer, which is weak. And if you bump it, it pops right off. So what I did was wrap string and then glued the string. And I think that's going to work just fine. Seems really sturdy. So, oh, wow. All right. There's a couple spots where when it was thicker, it didn't quite match there, but I'm going to fill that in with something. It'll be really easy to do. Important thing is the shape turned out. Let's check this one out. Even easier. And that one turned out okay. It's a little bit of dust that collected in there when I was sawing it, but otherwise that's a really good impression. For the rubber ducky mix, this is 62.5 grams of calcium sulfate, and on the whiteboard I had written down the ratio I found worked best when you use iron oxide, which I am going to use for the rubber ducky, so that is, this amount is part of that ratio. 50 grams of powdered aluminum, pre-weighed. and a whopping 125 grams of iron oxide pre-weighed. Getting ready to pour it into these molds here. I filled this with some epoxy and kitty litter, which is what I make nozzles out of, but it filled the holes pretty well. It might be a little bumpy, but hey, whatever, as long as it looks like a duck, right? This is going to be these little cut sticks for once it's poured in. I can stick them in different places and let it harden so that I can pull it out when it's done. But right now, I'm just going to mix these powders together. So here's the calcium sulfate, in goes the iron oxide, and in goes the aluminum. I made more than I need, I'm sure, but I didn't want to run out. So I'm going to mix this up really well. I'm going to come back once this is mixed well and I've added water, etc. This actually looks like chocolate pudding, but yep, just a little thinner. You can see how it looks. To help the thermite mix not to stick, you can buy certain powders and greases, but I hear cooking oil works just as well on this Plaster of Paris. So here we go. All right. Okay, I'm done. Let's wait for that to harden up. I was going to originally pull these out as they are and then heat them on a hot plate, but instead of that, I thought, why not put the whole thing in the oven, dry it a little quicker, and hopefully solidify those sticks. After several hours in the oven, these dried out really well, but there is a slight problem, and that is that these sticks are not holding all that great. They're stuck, but they wiggle easy, and I even pulled this one out a tiny bit there before it holds. So the next plan was to chip away at the actual plaster of Paris all the way around and get the pieces out that way. I'm never going to use these as a mold again, so it really doesn't matter. So that's what I'm going to do next. The cleanup was an absolute nightmare, but it's clean, and these turned out better than I thought. Took the sticks out, of course, and if you put this together, you can roughly see a duck there. But I need to clean these up better and fasten them together. I'm going to do that off camera, and I'll be back. From the photo you saw, I went ahead and painted it, and the bill broke off of the original Thermite. So this guy, yeah, sorry dude, cut it out and glued it on here, and then I wrote on it for the eyes and the wings. And yeah, this is a castable Thermite rubber ducky, a true form of castable Thermite. It's going to go up in flames. I am going to take the time to delve into the copper oxide castable Thermite realm, and I've never done this, or have I ever seen it. I am going to use the original ratio of 5, 4, and 10 that I spoke of earlier, and of course that referred to the calcium sulfate, aluminum, and iron oxide. I'm just going to replace the iron oxide with the copper oxide. I have approximately 41 grams of copper oxide. I don't want to use it all, so I'm going to only use 30 grams. So if we rewrite this with the copper oxide instead of the iron oxide, we have calcium sulfate 5, aluminum 4, and copper oxide 10. So if I have 30 grams of the copper oxide, we divide that by 10 and we end up with 3 grams, which is essentially 1 part. So if we take that 1 part, we can then go to calcium sulfate. We have 5 here, so it's 5 times 3 grams is 15 grams. The aluminum is 4, so we go aluminum 4 times 3 grams is 12 grams. The final weights, therefore, are for our copper oxide castable Thermite, copper oxide 30 grams, aluminum 12 grams, and calcium sulfate 15 grams. 30 grams of copper oxide made in a previous video, pre-weighed. 12 grams of powdered aluminum, pre-weighed. 15 grams of calcium sulfate, pre-weighed. You've seen this movie before, adding the copper oxide, aluminum, calcium sulfate, and some water. I'll be back when it's ready. It's mixed really well, so I'm just going to kind of pound it all to the bottom and let this set up. The copper oxide castable Thermite was really strange. I tried to dry it out at room temperature. It wouldn't, so I put it in the oven, obviously with the cup at 170 degrees for about 2 hours, and it hardened up really well fast. But it swelled, and obviously the cup got melted. But that's where we're at, so I'm going to cut this thing out right now. Okay, there it is. You know, by golly, that looks like a chocolate muffin, actually. I got an idea. This was not intentional, but darn, this thing looks like a cupcake now. Possibly for a birthday party for a 1-year-old, in which case this would be the appropriate gift. For this very last castable thermite, I'm using basically candle wax here, melting it to put in the iron oxide aluminum mix. 40 grams of iron oxide ready to be used in the castable thermite using wax pre-weighed. 20 grams of powdered aluminum to be used for the same purpose, pre-weighed. I mixed the 40 grams of iron oxide and 20 grams of aluminum really well, and I'm just going to add it to this candle wax. This is more of just a test. I'm not going to do anything fancy. There will be no ducks. All right, it's a little runny. It looks like most of the powder is going to the very bottom, so I might just absorb some of this wax on top to thicken it up a bit. Using paper towels, I absorbed probably a third of the wax that was in there, so if you do this, just beware of that. It's a decent consistency here. It's definitely moldable. Yeah, so I'm going to pour this out and we'll light it, see what happens. I can't use a plastic or styrofoam cup for obvious reasons. This stuff will definitely melt it, so I made a little thing here out of aluminum foil, just a little square thing. Okay, like everything else, let's let it harden up. If this burns, this went really well because I was able to take the aluminum foil off of this without any problem. And look at the bottom, all the little indentations. It's certainly castable for sure. And yeah, just hoping it works. Kind of looks like a brownie. Okay, enough. It's time. Let's go light these. This is an old air purifier that has not worked for years. I was going to open it up and take the electronics out for other uses, but I found a much better purpose for it. Lighting the copper oxide cupcake thermite. Obviously, I've tried multiple attempts, including using just a small lighter to get it going, but this is it. I've got a torch. So if it doesn't start with this, I'm unfortunately going to have to call this a fail. Now, the plastic's obviously on fire. I'll put that out with the snow, but sorry, we're going to have to call this one quits. This is the wax, iron oxide, and aluminum. In theory, this should have worked just fine. I think, of course, there was just too much wax. If you do this, make sure you use the least amount just to keep the mix together, and I think you will have success. I originally wanted to find a way to make this float in water, but recent weather changes made that impossible, so this is ice, and I just spray painted it blue. Honestly, this is a little hard to do, but here it goes. Hanging out with his buddies. Maybe the cold air has something to do with it, I don't know. That was the calcium sulfate, aluminum, and iron oxide thermite. It did okay, burned a little slow, but hey, I'm alright with it. It's continuing to burn under the water. This is really something. I mean, it's underwater. Remarkable. Alright. Hope you enjoyed it.